the definition of absolute value is no matter what we put inside the absolute value sign, it's going to put out, the output is positive. Okay? So, there's a process to solve an absolute value equation. So the first thing you have to do is isolate. We're going to isolate the absolute value. Then we're going to make two equations. And the reason I'm making two equations, if I put a 6 inside the absolute value, I get 6, right? But if I put a negative 6 inside the absolute value, what do I get also? So the 6 and the negative 6, we don't know which one we're going to use. And that's why we get two equations. We're going to solve each equation. We're going to check our solutions using the original problem. We're going to check our solutions using the original problem. And we're going to identify any extraneous solutions. Y'all, what's an extraneous solution? If you had to guess.
Outside.
It's right, it's an extra. Like, it doesn't work. It's going to make this true, but it is not included in the solution set. And 6, we're going to include only our solutions. We're going to include only our solutions, not the extraneous solutions. So the very first step was to isolate the absolute value. I'm going to isolate the absolute value. This absolute value is isolated. Can I get negative 6 for a solution? When we looked at the graph, were there any negative y's? So this is no. When the absolute value is isolated, it cannot be set equal to a negative number. Now, if it's not isolated, we can set it equal to a negative number. But when we get this by itself, if it equals a negative number, there's no solution. Okay, so let's work a couple problems. So look at example 1. Is the absolute value isolated? Why is it not isolated? I'm multiplying by 2. How do we undo multiplication? So when I divide, do I divide in the absolute value? No, it's just like the parentheses, right? Only outside. So when I divide, now I have 3x plus 4 equals 10. Now is the absolute value isolated? If now the absolute value is isolated, now we want two equations. So I'm going to take what's inside the absolute value, and we're going to use it twice. I'm going to have 3x plus 4 equals a positive answer. And then I'm going to write the 3x plus 4 again. And I'm going to set it equal to a negative number. I'm going to solve. So I get x is 2. And I'm going to do this again. I'm going to subtract 4. And divide by 3. Okay, everybody grab. 2 is the problem you missed the most. Does it? Go ahead and get caught up. Then you do it. All right. For the next one now. Is the absolute value isolated? So is it okay if I just take 4 minus 9? Yes or no? Why? If the answer is no. Why can I not do that? What am I doing with the 9? I'm multiplying, so we can't take 4 minus 9. So how do I get rid of the 4? Right, it's a plus 4, so we're going to subtract 4. And now I want to isolate the absolute value, so I'm going to divide by negative 9. Can I make the 2 equations now? All right. So see if you got the right answers. Did anybody check these? Did they work? They both work. Okay. They both work. All right, for example 3. Okay. So, is the absolute value isolated? Yes or no? The absolute value is isolated, so I'm going to have 2 equations. I'm going to have 2x plus 4 equals 4x, and 2x plus 4 equals negative 4x. You recopy what's under here, 2x plus 4, 2x plus 4, and you do 1 positive and 1 negative. And then solve for x. So if I subtract the 2x, so if I put the 2 inside the absolute value, I get 2 times 2 is 4, plus 4 is 8. And if I take 4 times 2, I get 8. So 8 equals 8. So this one checks. So next, we have the negative 2/3, right? Y'all, look at the negative 2/3. I have to multiply it times 4. If I multiply the 4 times the negative 2/3, what do I get? Negative 8/3. Can the absolute value equal a negative number? So what is true about this? This is extraneous. So only the 2 works. What about example 4? What do I do first? So if I subtract the 8, what do I get? Can I have that? This is no solution. For example 5, I have to isolate the absolute value of x minus 5, so what do I do first? Add what? Add 9. So if I add 9, then I'm dividing by 4. So how do we undo dividing? So I'm going to multiply both sides times 4. So I get these two equations. And these both work. Okay. For example 6 is the absolute value isolated. All right, so I'm going to do 4x minus 1 equals 2x plus 9. That's my positive one. But then I also have to do negative. So I'm going to start with the positive. If I subtract the 2x, so we get x equals 5. So to do the next one, what do I have to do? Distribute the negative. So if I start with that, I do 4x minus 1 equals minus 2x minus 9. We get x equals a negative 4/3. All right, so let's check the 5. If I put the 5, I have 4 times 5, which is 20, minus 1 gives me 19. On the other side, I have 2 times 5, which is 10, plus 9, and that gives me 19. So the 5 is a check. Now we have to check the minus 4/3. So pick up your handy dandy calculator. Take 4 times negative 4/3 and subtract 1. Negative 19 over 3. Okay? So then take negative 4/3, take 2 times negative 4/3 plus 9. What do you get? Positive 19 over 3. So, do they match? No. So this one is extraneous. Okay. Any questions on this? Does anybody not know how to type it in a calculator? Got it? You got it? Did you get this answer? Did you get it? Did you get these answers? Okay. Now, what do I have to do the next one? Divide by 2, and then we do a positive and a negative. Do we need to see this? Yes? Okay. Go ahead and everybody get your answers and we'll compare. When we check 10, if I put 10, 6 plus 10 is 16, times 2 gives me 32. 10 times 4 is 40 minus 8, that gives me 32, so this one checks. The negative 2/3, if we put that in, what do we get? 6 minus 2/3 times 2. What do we get on the first side? 14 over 3. What'd you get on the other side? It's negative, right? Do they match? Like, do I even have to find the answer? Are they going to match? No, because this is gonna, negative minus makes it negative. So this one's positive, this is negative, so this is extra. We put the negative 2/3 right here. 6 minus 2/3. And then times 2. Is what? This? Yeah. 32 over 3 and then negative 32 over 3. Oh, it is 32 over 3. This side is 32 over 3. But it doesn't matter because this is positive and this is negative. They're not going to match, right? It literally doesn't matter what the numbers are. They can't match. It's extraneous, so it doesn't matter. You can't have one positive and one negative. That makes it extraneous. Okay, on the last one. A thermometer comes with a guarantee that the stated temperature differs from the actual temperature by no more than 1.5 degrees Fahrenheit. Write and solve an equation to find the minimum and maximum actual temperatures with a thermometer is 87.4. So y'all, first of all, what's the difference? What do they want to know the biggest difference can be? There's only two numbers. Is the difference 87.4 or is the difference 1.5? It's the 1.5. That goes on the equal side by itself. And the rest is an absolute value then. And what I'm going to do is I'm going to take the temperature minus the 87.4. And you're going to get two answers then. I'm going to get x minus 87.4 equals 1.5. And x minus 87.4 equals negative 1.5. If I add the 87.4, I get 88.9. And if I add the 87, I got 85.9.